Cosmic voids are enormous regions of space containing almost nothing. No galaxies, stars, planets, or matter. These empty zones stretch hundreds of millions of light years across, creating vast deserts in the cosmic landscape. The Bode's Void, discovered in 1981 by astronomer Robert Kirshner and his team, spans roughly 330 million light years in diameter and contains only about 60 galaxies, instead of around 10,000, based on the average universal density. These voids form through gravitational effects that pull matter away from certain regions over billions of years. As galaxies attract each other through gravity, they cluster together, leaving behind these enormous empty spaces. Think of it like bubbles in Swiss cheese. The cheese represents galaxy clusters, and the holes are the voids. What makes them particularly unsettling is how they challenge our understanding of matter distribution in the universe. The Eridanus supervoid is even larger, spanning over 1 billion light years and correlating with a mysterious cold spot in the cosmic microwave background radiation, the afterglow of the Big Bang. Some scientists speculate this could be evidence of a collision with another universe, though this remains controversial. These voids may also hint at the universe's future. As dark energy accelerates cosmic expansion, galaxies will drift further apart, leaving each isolated in darkness. Dead galaxies are massive cosmic graveyards where star formation has completely ceased. Unlike active galaxies that create new stars from cold hydrogen gas, dead galaxies have exhausted their stellar fuel supply. Without raw materials to ignite new suns, these galaxies slowly fade as their stars burn out. The James Webb Space Telescope has detected these galactic corpses drifting through space, appearing reddish as they burn through their final energy reserves. They form when galaxies run out of cold hydrogen, essential for star formation. This can happen when the gas heats too much to collapse into stars, is blown away by stellar winds, or is used up over billions of years. What makes dead galaxies truly frightening is their inevitability. Every galaxy, including our Milky Way, will eventually exhaust its fuel and go dark. On a cosmic timescale, scientists predict the universe will enter the dark era, where all stars have died and the cosmos becomes a cold, lightless void. Dead galaxies represent the mortality of galaxies, containing hundreds of billions of stars, all destined to fade into darkness. Magnetars are neutron stars with magnetic fields a quadrillion times stronger than Earth's, making them the most powerful magnetic objects known. They form when massive stars collapse during supernova explosions, compressing a sun's worth of material into a 20-kilometer sphere. This rapid, violent collapse twists space-time, generating extremely intense magnetic fields. If a magnetar were where our moon is, it would instantly erase all electronic devices on Earth and tear atoms apart from 1,000 kilometers away. Its magnetic forces can distort matter. A starquake is when a magnetar's crust shifts just a centimeter, and it releases more energy than our sun produces in 100,000 years. Its magnetic field lines stretch, snap, and unleash gamma and X-ray bursts across space. In 2004, the Magnetar SGR 1806-20 caused a flare that disrupted Earth's atmosphere from 50,000 light-years away, the most powerful event recorded beyond our solar system. Magnetars are unpredictable. They can stay dormant for years and then suddenly explode with lethal radiation bursts within several light years. If one flared within 50 light years, it could strip away Earth's ozone layer and cause mass extinctions. Rogue black holes are stellar mass black holes that have been violently ejected from their birthplaces and now wander the galaxy as invisible cosmic predators. Unlike supermassive black holes at galactic centers, these rogues drift freely through space, following trajectories set by gravitational interactions from millions of years ago. Scientists estimate 100 million of these objects could be roaming the Milky Way. They form when massive stars die in supernova or when black holes are ejected from galactic centers through collisions or gravitational interactions. Their main danger is their invisibility. They emit no light and are too small to cause noticeable gravitational effects until dangerously close. A rogue black hole could head straight for our solar system without our knowledge. In 2022, astronomers confirmed the first detection of a rogue black hole via gravitational microlensing by observing how its gravity bent light from a background star. It was found 5,000 light-years away, moving at 45 kilometers per second. If one passed through our solar system, its gravity could disrupt planets, flinging Earth into the sun or into cold interstellar space, both scenarios ending life as we know it. By then, it would be too late to take any action. Gamma ray bursts are the most powerful explosions in the universe since the Big Bang, releasing more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. These catastrophic events occur when massive stars collapse into black holes or neutron stars collide and merge. The explosion creates two narrow beams of gamma radiation that shoot out at nearly light speed, so focused and intense they can be detected from billions of light years away. Here's what makes them terrifying. Gamma rays travel at light speed, meaning there would be zero warning. No detection is possible. One moment everything is normal, the next Earth would be bathed in deadly radiation. If a burst occurred within 6,000 light years and pointed at us, it could strip away our ozone layer in seconds. The burst might last only minutes, but the aftermath would expose Earth's surface to lethal ultraviolet radiation, killing most life. Scientists have found evidence suggesting gamma ray bursts cause some mass extinctions. The Ordovician extinction 450 million years ago eliminated 85% of marine species and shows patterns consistent with a gamma ray burst impact. The most unsettling aspect is their unpredictability. They could happen anywhere in our galaxy at any time. There's no defense, no warning system, and there's no way to prevent it. The Great Attractor is an invisible gravitational anomaly pulling our entire local group of galaxies, including the Milky Way, toward a region 200 million light-years away at 600 kilometers per second. Discovered in the 1970s and 80s, it remains one of the universe's great mysteries, because we can't see what's pulling us. It's hidden behind the zone of avoidance, obscured by our galaxy's dust and stars and the constellation Norma. This means we're racing through the universe at over 2 million kilometers per hour towards something we cannot observe. Recent observations suggest it's part of the larger Shapley supercluster, containing tens of thousands of galaxies. The unsettling aspect is that there are massive, unseen structures shaping galaxy motion. Some scientists believe the Great Attractor itself may be moving toward an even larger structure. And our Milky Way is on a collision course with Andromeda, set to impact in 4.5 billion years. We're passengers on a cosmic vehicle with no brakes, heading toward an unseen destination. Black widow pulsars are rapidly spinning neutron stars that devour their companion stars through intense radiation and gravity. Named after the spider that eats its mate, these pulsars blast their partners with powerful stellar winds and radiation, slowly stripping away the companion's outer layers until only the pulsar remains. The victim star is gradually vaporized, feeding mass to the predator. Vampire stars operate similarly but through a different mechanism. They siphon material directly from neighboring stars via gravitational theft. As the vampire star pulls hydrogen and helium from its companion, it grows more massive and luminous while its victim dims. This cosmic parasitism can lead to explosive, dramatic ends. When enough material accumulates, it can trigger violent outbursts or destabilize the dying star. These stellar predators show that even on cosmic scales, relationships can be fatal. Entire systems exist where one star slowly kills another over millions of years. What makes this unsettling is how common these systems are. Astronomers have identified dozens of black widow pulsars and hundreds of vampire stars in our galaxy. In space, stars don't just die from running out of fuel, they can be murdered by neighbors, torn apart by radiation, or drained of their life force in cosmic horror stories. Some exoplanets have conditions so horrifying they seem plucked from science fiction, yet they exist. HD 189733b, a gas giant 64 light-years away, experiences sideways winds reaching 8,700 kilometers per hour, 7 times the speed of sound, carrying clouds of molten glass. This glass condenses from atmospheric silicates and rains down like cosmic shrapnel, shredding anything in its path. The planet is essentially a permanent hurricane of razor-sharp glass moving faster than bullets. Kelt 9b represents the opposite extreme. Surface temperatures exceed 4,300 degrees Celsius, nearly as hot as some small stars. The daytime side is so hot that molecules break into atoms, and iron exists as vapor. The planet is slowly vaporized by its star, leaving a comet-like tail of escaping gas. Other hellish worlds include planets locked in tidal orbits, where one side faces the star, creating hemispheres of eternal inferno and darkness. Some orbit very close to their stars, completing a year in less than an Earth day. Others are rogue planets, ejected into interstellar space with no sun. These environments show how rare Earth-like conditions are. Most worlds would kill humans instantly. Dark flow is one of the most mysterious phenomena in cosmology. Massive galaxy clusters across billions of light years appear to be moving in the same direction at over 600 kilometers per second toward a specific region of the sky, and we have no idea why. First detected in 2008 using data from NASA's Wilkinson Microwave Anisotropy probe, this unexpected motion defies our understanding of the universe based on the Big Bang Theory and cosmic inflation. What makes dark flow so unsettling is what it suggests: something enormous and unknown outside the observable universe. Galaxy clusters as far as 2.5 billion light-years away are all being pulled toward a region beyond what we can see, hinting that something exists beyond our cosmic horizon. This could be a massive structure, a gravitational anomaly, or even the influence of another universe. Some theories propose dark flow is caused by gravitational pull from beyond our observable universe, which we may never observe directly since light from that region hasn't reached us. Others suggest it could be evidence of the multiverse, with our universe influenced by neighboring ones. It's like detecting ripples in water without knowing what caused them or how massive the source might be. The edge of the observable universe isn't a physical boundary, but a horizon beyond which we cannot see because light from those regions hasn't had time to reach us since the Big Bang. This cosmic horizon lies about 46.5 billion light-years away in every direction, not 13.8 billion, despite the universe's age, because space itself has been expanding faster than light, carrying distant galaxies away as their light travels toward us. What makes this boundary truly terrifying is the unknown beyond it. Past this edge may lie countless galaxies, perhaps different laws of physics, alternate universes, or structures we can't even imagine, none of which we can observe or reach. Everything beyond this horizon is forever invisible, cut off by the limits of light and time. Even more unsettling, galaxies near the edge are moving away so quickly due to cosmic expansion that they will disappear from view forever, leaving us in a darkening universe. Over trillions of years, distant galaxies will fade as they cross beyond our cosmic horizon. The observable universe will shrink as more of the cosmos becomes unreachable. Eventually, local galaxy groups will be isolated, surrounded by darkness in every direction. We may already be surrounded by wonders, cosmic events, and perhaps civilizations, all beyond our reach, separated by the fundamental structure of space-time itself. Thanks for watching. If you enjoyed exploring these cosmic terrors, make sure to subscribe. There's so much more of the universe's strangeness to uncover. Check out the next video to continue the journey.